Okay, we're going to go through lesson 2.8, which is about solving inequalities. Just a heads up, this is the last section in Unit 2, so there will be a test coming up pretty soon. All right, so what we're going to be doing first is just determining where this equation that you have in example 1 is 0, where the equation is positive, and where the equation is negative. So for part A, determining where this function is 0, this is something we have done already. Basically, all it means is you're going to take your function and you're going to set it equal to 0. And you're going to solve for x, which is already factored. So that means we're just going to take each of our factors and set each one equal to 0 and solve. So for the first one, if I solve for x, I would get -3. And the second one, I would need to square root and then add. So I'm going to get positive 4 for my two answers. Now, to determine where the function is positive and where the function is negative, what I'm going to do is I'm going to use the answers from part A. And so I'm going to start by making a numbered line. And on my numbered line, I am going to put the 0 values that we have here. So we have -3 and we have +4. Those are the only two things I'm going to put on my numbered line. So here's the deal. I want to know where the function is positive and where the function is negative. I know that at -3, the function is equal to 0. And I know that at 4, the function is equal to 0 because I just solved that by hand. So that means that before -3, it's got to be positive or negative, and then it goes to 0, and then it does something else, goes back to 0, does something else. So I'm going to do a little test to see what my function is doing in each of these intervals. And so to do this, I'm going to pick a value that is smaller than -3. So maybe we'll just do -4. And I'm going to plug that into the function to see what we would get as far as an answer. And I'm just looking to see if it would give me a positive answer or a negative answer. So I'm taking -4 and I am plugging it into the function up here. So that would give me -4 plus 3 times -4 minus 4 squared. And then I would get, let's see, -1 times -8 to the second power is -1 times 64. So it's a negative number. It's -64, but we don't really care about the fact that it's 64. We just care that it's negative. So I'm going to put a little negative sign right there. Okay, we're going to do that again from -3 to 4. We're going to pick a number that is between -3 and 4. 0 seems like a good choice because it's in that interval, and you're going to plug that in for x. So you would get 0 plus 3, 0 minus 4 squared. This will give you 3 times 16, which is positive 48, which again just matters that we got a positive. So let's put a plus there. And then one more time. So we're going to test a number that is bigger than 4. So 5 is the first thing that comes to mind. And we're going to plug that in. Simplify and you get 8 times 1, which is 8, right? So then that means that this interval is also going to be positive. So now we can answer the question. Actually, let me scoot this down a little bit. Let's answer the question. Where is the function positive? The function is positive from -3 all the way up. So we're just going to call that from -3 to infinity. Where is my function negative? My function is negative from -3 down, which I would call negative infinity to -3. You know what? My positive answer is not right. That was kind of silly. I can't say it's positive at 4 because it's 0 at 4. So I need to say -3 to 4 and then 4 to infinity. My mistake. There's another example that I've already completed here, most of in the notes. I'm going to attach the PDF of this as well. But I forgot to put the answers for the positive and negative intervals, so I'm going to do that. I wrote my sign chart already, and it's written in a little bit of a different way. more of like a table format rather than a number line, but it means the same thing. So down here, where is the function positive? I'm looking for the plus signs, which occur at -3 to 1/2, as well as 5 to infinity. And then D, the one, let's see, -infinity to -3, and then also from 1/2 to 5. So you can take a closer look at that when you are finished with this video. It'll be in the PDF of the notes. All right, let's look at something different. So it says solve a polynomial inequality analytically. So what we're going to do is we're going to have to solve this equation first using synthetic division. So we're going to begin by doing P over Q. And this is like what we've been doing for a while now. So I need to list all the factors of 6 and divide by all the factors of 1, which would just be dividing by 1 would leave it as the same. So all of these are possible numbers that would divide my function evenly. I'm going to try 2, and I'm trying 2 because I know 2 is going to work because I already did this problem. So I'm going to try 2, do synthetic division, make sure that I'm getting a remainder of 0. And there you go, 2 works. So I know that I can have a factor of 2. So I know x minus 2 is a factor. I also know from this bottom row of my synthetic that x squared minus 2x minus 3 would also be a factor. And so what I'm going to do from here is I'm going to keep factoring all the way down. So what times what equals -3? That adds up to -2 would be -3 and plus 1. So now we have our function fully factored. And now we're going to solve it to find the zeros. So the zeros would be 2, 3, and -1. And we need to know that so that we can set up our sign chart. So let's go down to the sign chart here. I need a -1, I need a 2, and I need a 3. And it doesn't matter how evenly spaced they are. It's just to organize your information. Now you're going to do what you did last time. So you're going to test some points that are in each interval, and you're going to see whether your function is positive or negative in those intervals. So I'm just picking some numbers that are inside of each interval, and I would go through and plug all of these numbers into the equation. Now you can plug it into the original equation, or you can plug it into the factored form. It doesn't really matter, whatever you think is going to be easiest for you. So you can pause the video now and try to do that yourself and hit play when you're ready. So what I found when I plugged my numbers in is I found that this was negative, then positive, negative, then positive. Okay, go back to your answer and read the question again. So this is asking, when is the polynomial less than or equal to 0, which means when is the polynomial negative? Because less than or equal to 0 means negative numbers. So if you look at your sign chart, when is this function negative? This function is negative. Let's see. From -infinity to -1, and again from 2 to 3. One more thing we need to address is the fact that this says, when is it less than or equal to 0? So that means if your function is equal to 0, then you would include those values in your answer. Well, where was our function equal to 0? It was equal to 0 at all these benchmarks, -1, 2, and 3. All of those numbers are in our solution set. So all we're going to do is we're just going to make these into brackets so that it includes those values in our answer. Okay, this one is solving a polynomial graphically. So this would be a question where I would allow you to have a graphing calculator And I would be asking you to solve this inequality using that graphing calculator, meaning like this one's not going to factor nicely, so I'm trying to give you another option. So the first step would be to put all of your terms on one side like I have shown here, and then you're going to graph in your graphing calculator or in Desmos or something like that. You're going to graph y equals x to the third minus 6x squared plus 8x minus 2. And when you graph that, you're going to get this function over here that kind of looks like a cubic function. So then from this point, you need to read your question again. It does say, when is the polynomial, the sign is less than or equal to 0. And so again, less than or equal to 0 means when is that function negative? So graphically, you're just looking for when the line is below the x-axis. So it would be those two blue areas. When is it below the x-axis? And then you just kind of turn it into a set of data. So like this blue one here is below the x-axis from negative infinity up to 0.325. This does say when is it equal to 0, so we do want to include those endpoints in our solution set. And then it's under the x-axis again from 1.461 to 4.214. And again, we do want to include those in the solution set because it does say that anything where it's equal to 0 also counts. Okay, inequalities with unusual answers. So let's begin with finding the zeros, which means we would need to factor and solve for x. Quick review, if you wanted to factor x squared plus 4, you would have to use imaginary numbers to do that. In a 0 value, we're not going to use imaginary numbers. So even though an imaginary number is part of the factorization, we will not use it for things like this because it's not a real number. So 3/2 is the only 0 value that I have. So let's make a sign chart. And let's put 3/2 on our sign chart since it's the only real number that gives a 0 or a solution. 3/2 is the same as 1.5. So something smaller than 1.5 would be 1. Something bigger than 1.5 would be 2. I don't know, maybe you could use something different, but anything smaller or bigger than that number will work. And you're going to plug it in to see what happens. So if I plug in 1, I would get 5 times 1 squared. So this is a positive number. Oops, wrong side. Positive number. If we plug in 2, we get, let's see, positive number would be, 8. And then over here, 3 minus 4 would be negative 1 squared. Okay, it's another positive number, which is interesting. So the first question says, when is the function bigger than 0? So when is the function positive? Well, look at your answer. Your function is positive everywhere except for at 3/2, and at 3/2 the function is equal to 0. So we're going to list negative infinity to 3/2 and 3/2 to infinity. Do not include brackets because we're not looking at when it's equal to 0, just greater. Okay, when is the function greater than or equal to 0? Well, we already said it's greater than 0 everywhere except 3/2. Well, where is it equal to 0? It's equal to 0 at 3/2. So where is it greater than or equal to 0? It's greater than or equal to 0 everywhere. So negative infinity to infinity. When is the function less than 0? So when is the function negative? The function is negative nowhere. So this one would be no solution. Okay. When is the function less than or equal to 0? Well, as we said, it's not less than 0 anywhere, but it is equal to 0 in one spot. So because it's only one value, you would just put x equals and list that value. Okay, some more complicated inequalities. So like this one here, you're going to start by saying, like taking each thing and setting it equal to 0 to solve and find your 0 values. So you get x equals 2 for the first one. Now, with the radical, remember radicals have a different kind of situation where you have to kind of explain the domain restrictions. So the inside of a radical has to be greater than or equal to 0, which means that x has to be greater than or equal to -1. That also means that your function cannot exist if x is smaller than -1. You can also set the square root equal to 0 and solve that. You would have to square both sides at the beginning, which would still just give you 0, and then subtract 1, and you're off to a good start. Now, we're going to do a sign chart just like we have been doing. And it's going to have -1 and +2. And we're going to make a little note here. We already said that our function can only exist when x is greater than or equal to -1, meaning it's not defined anything less than -1. So I'm just going to put not defined right there in the graph or in the sign chart. And then I can go ahead and continue finding whether my function is positive or negative in those intervals. So from -1 to 2, the function I got to be negative, and then positive from 2 on. So let's go back and answer the question. Question says, when is this whole function less than or equal to 0? So when is the function negative or equal to 0? The function is negative from -1 to 2, and it is equal to 0 at -1 and -2. So we're going to go brackets, -1 to 2 with a bracket. Here's another example of something that's kind of similar to example 6. So you could pause the video and try this one as well.